Great. So let's take this example and see how we can solve them. Okay. So in this question, we are saying that three functions f, g, and h are defined on the set of real numbers by f such that x maps onto 2x plus 3, j such that x maps onto 3x minus 1, and h such that x maps onto x squared. And we are to find the following. So we are going to take them one after the other. Previously, we've already looked at some examples. We are going to do further examples on this. So we shall not waste much time. Let's take them one after the other and look at how we can solve them. Okay, great. In this case, I will begin with our first, which is what? My A. Okay, so A is giving us F followed by G. F followed by G, which previously in the properties we said that when you are given this, it means that you are going to find the domain of F at X should be in the domain of what? J. So it means that my J is out. Then I'm going to put the function f at X into the function G. Okay, great. But before that, what is my function f and G? So let me write my function, that is f at X is giving us 2x plus 3. My G at X is also giving us 3x minus 1, and my h at X is also giving us what? X squared. Great. So once we have that, it means I'm only going to put the entire function into what? Function G. Wherever I see X, I'm going to put everything here. So if that is the case, then my G OF is giving us. So what is G at X? G at X is what? 3. And we are saying that we should substitute the function f at X for X in the function G at X. So it means that I will put, in place of X, I will put the entire function of f at X there. Okay, minus my 1. Okay, good. So I'm going to open brackets. Now I'm going to get yes, so 3 times 2 gives me what? 6x. This times this gives me what? Plus 9 minus 1. And my final answer is 6x plus 8. And that is it. Okay, that is it. So as I said earlier, the questions, these are very what? Basic. Now let's look at the B part. So for the B part, we are given this. Okay. So when you are given this, remember, and the properties we looked at, we said when you are given this, it means that you are going to put so you bring your O here, you are going to put J O H in what? F. So first of all, you need to work out for G O H. Okay, and that also means we are going to put H at X in what? G. So what is my H at X? It means you're going to put X squared into what? G. And that will be what? 3 x squared minus 1. And that gives me 3x squared minus 1. Great. Now, once I have gotten this, and this is for what? GOH, H followed by G. So it means after that, then I'm going to put the entire also thing in F. Okay, if that is the case, then my FOGOH is then given as, so whatever I see X in F, I'm going to put everything here. Okay, if that's the case, then I'll have my 2 out, I open bracket and write everything here. Okay, great. Then plus my 3. If that is the case, then let me open bracket. This time this gives me what? X squared. 2 times -1 gives me -2 plus 3. Okay, good. If that's the case, then my final answer becomes 6x squared plus 1. And that gives me what? My answer. Okay, yes, for the second one. Now let's look at the C part. So my C is also given as, good. So you remember the property, this property, we said that you can also write this property as f at x. Yes, like this. It means that we are going to put the function f into its what? Inverse. Or you can even do it as it is. You can also put the inverse of f into the f itself. And how you do it, whether you put f as the function into this or you put the inverse into the function, you are at the end of the day you are going to get the same thing, but we just want to follow the properties. Okay, great. Now you know that in such situation, how do you even do it? Before that, you need to find the inverse of what? F. So we are saying f at x is given as what? 2x plus 3. So how do we find inverse? Remember what we did previously. So before you find the inverse, you need to let your y equals f at x. So it means y is equal to 2x plus 3. Okay, now when you are done, what do you do next? What do you do is you only what? Interchange. You only interchange x and y. So here I'll write x is equal to 2y plus 3. Then what do? You solve for y. Okay, that means you make y the subject. Then I can write here as 2y is equal to x minus 3. Am I right? Yes, I'll only what? Send this one here, transpose 3 here to make negative and maintain this, but I just change their position, so I'm right. Now we just divide both sides by 2, which will give me what? So I'm continuing from here to here. So it means that my y is equal to x minus 3 divided by what? 2. Now we said that after finding y, what do? You have to replace what? The y by its inverse, that is f. So it means that I will just write f inverse, which is equal to x minus 3 all divided by 2. Good. Now, once we have calculated for the inverse of this, the rest is very easy. We are only going to, because it says we should substitute the function f at x into h what? Inverse. So I'm going to put everything here, entire thing here, into its inverse. Wherever I see x, that is what I'm going to write there. Okay, great. If that is the case, then the FOF is then given us, so I'm going to put everything there, and then we have 2x plus 3 minus the 3 all divided by 2, and we know that this is negative, this is, so I'm going to get 2x divided by 2, where these two will go, then the answer becomes what? X. Okay, so it means that therefore or okay, so let me write it here. Therefore f inverse is giving us X, and that's our answer. Okay, good. Now let's look at the D part. Okay, let's look at the D part. So for the D part, I previously said that when you have this property is different from when you have F O, like the second the C part. Okay, this one, they are not the same. Note that this is G, this is F. They are of what? Different functions. But looking at this one, FF, so it is a function and H what? Inverse. So whatever position you do, whether you put F in what the F inverse, or you put the F inverse into the F, you are going to get the same thing. But in the case of this, you cannot say when you put G in the inverse of F, you are going to get the same as when you put the inverse of F into G. No. So you need to work it as it is. Okay, it should follow the same way, meaning that the domain of the inverse of F should be found in the domain of what? G. So I'm going to first work out for this. The answer I get, then I substitute. So it means that this is what is going to be. My G should be out and have my inverse this. There, that is what it means. Okay, great. If that is the case, now we are in the D part, the C part. We already calculated for the F inverse, where we said it is what it is X minus 3 all divided by 2. Okay, that is what we got for F inverse. So what we are doing, that we are only going to substitute this into what? G. And what did we get for G at X? For G at X is giving us what? 3x minus 1. So for this, we are saying that we are going to substitute F inverse into G, meaning that wherever I see X in the G, okay, X in the G, I'm going to substitute the entire function here, the inverse of F. If that's the case, then I will keep my 3 here, open bracket, and put everything here, where it is X minus 3 all divided by 2, okay, minus 1. So if I move to open a bracket, then I'm going to get 3x minus 9 all divided by 2, okay, minus what? 1. If that's the case, then I'm going to get 3x minus 9 minus 2 all divided by 2. And this gives me 3x minus 11 all divided by 2. So that gives me that. Now let's look at the last part. Okay, let's look at the last part. Great. So you remember this property as well. We said that when you are given this, it means you take the inverse of each of them, but it should be the reverse part, meaning that you are going to have this H inverse of F inverse, okay, and that is H inverse should be following what? F inverse. That is what it means, okay. So when you have it like this, even though you see that the F comes first, but when you are doing this property, so my dear students, I will urge you to take note of this, particularly this one, most students make mistake. They will take the inverse of this, and make sure the inverse of h will rather what be substituted into the inverse of f. No, the inverse of f should rather be substituted into what the inverse of h. So take note of that, okay, so that when the question is given to you, you don't make such mistakes. So for such example, before you can do that, you need to find the inverse of each of them. Meanwhile, we have already calculated for inverse of f. We are only going to find the inverse of each. Good. So we know that h at x was given as x squared. If that is the case, then for inverse, we let y equals what? H at x. If that's the case, then y should be equal to x squared. Just interchange what their positions, and then you have x is equal to y squared. Then you make what? Y the subject. In that case, it takes square root of both sides, and that is y is equal to square root of x. After that, then you know that h inverse is this, so you are going to substitute h inverse for y. If that's the case, then I'll write this here, which is equal to root x. Good. So now we have that, so we can proceed to solve this. Okay, so we know that this is what we are going to look at. Okay, but what is our f inverse? Our f inverse is giving us what? X minus 3 divided by 2. So it means I'm going to substitute this f inverse into this what? H inverse wherever I see x. If that is the case, then I'm going to write square root of x minus 3 all divided by 2. Therefore, f o h or inverse is giving us square root of x minus 3 divided by 2, and that's it. Okay, so you see that for composite function, very basic. This is very easy, it's not difficult. So my dear students, please, when you are dealing with this, take your time and you get it easily. Now let's end here and continue next time. Now this brings us to the end of functions. Yes, it was very great to take you through this concept, functions, mapping, relations. Yes, so my dear student, I urge each and everyone to solve more examples on this concept. Now in our next concept, we are going to look at polynomial functions. Okay, good. So that will be our next concept. So I will urge each and everyone to read more on polynomial functions. Okay, all right. Now I'm your mathematics facilitator, Evans. Okay, the name of the channel is Mazris TV. Don't forget to add your submission under the comment section. So see you in our next video. Bye bye.